The information presented in this channel is compiled with the assistance of AI, public sources, and independent analysis. While every effort is made to ensure accuracy, information may contain omissions, inaccuracies, or interpretations. Content is provided solely for educational, case study, commentary, and entertainment purposes and should not be considered financial, investment, legal, or professional advice. Take a quick second to like the video and subscribe to the channel so you never miss an operational breakdown. How will Google split its limited compute resources between legacy high-volume search engines and heavy generative AI loops? Why are custom TPU chips giving Google an insane performance per watt advantage over pure software firms? How does Google's endless data flywheel make its core search product completely impossible to replicate? How can Google stop agile AI startups from poaching its elite engineering and DeepMind talent? Why is Google buying and leasing a massive private network of deep oceanic fiber-optic cables? How can Google protect its raw data moats as public web scraping becomes increasingly restricted? To what extent should Google shift its hardware focus from centralized cloud servers to local smartphone edge AI processors? Why is Google's multi-billion-dollar data center footprint an absolute wall against standard market competitors? How can code optimization from a tiny group of researchers save Google hundreds of millions of dollars in processing costs? How does Google plan to overhaul its storage ingestion systems to clean and compress training data? How will consolidating historical metadata into a single graph asset accelerate conversational AI lookup times? How does Google automatically route computational requests away from overheating data centers to regions with clean energy surpluses? How can large neural network models be compressed into lightweight software assets that require fractional processing power? How does machine learning predict cooling system degradation before a mechanical server failure occurs? Why is Google deploying upgraded hardware encryption modules across all multi-continental underwater fiber landing stations? 7. Key resources. Key resources are the strategic engines, physical infrastructure, and intellectual assets that Google leverages to build its value propositions, reach its distribution channels, and sustain its global market dominance. 8 cases, core assets within Google. Case 1, hyperscale global data centers, a massive physical footprint of custom-engineered data facilities worldwide, ensuring low-latency processing and continuous service availability. Case 2, custom TPU silicon, tensor processing units proprietary, application-specific integrated circuits designed explicitly to accelerate machine learning workloads and reduce reliance on third-party hardware. Case 3, unrivaled proprietary datasets, decades of indexed search histories, continuous mapping telemetry, crawling indices, and petabytes of user-uploaded video metadata. Case 4, foundational AI research architectures, deep learning models, transformer frameworks, and multimodal neural systems developed by internal research arms. Case 5: Elite engineering and DeepMind talent, a highly specialized global pool of computer scientists, data architects, AI researchers, and cybersecurity engineers. Case 6: Deep oceanic fiber network, ownership and multi-regional leases of thousands of miles of private undersea fiber-optic cables connecting continents securely. Case 7: Global brand equity, an invaluable intangible resource where the corporate name Google acts as a near-universal active verb for information gathering. Case 8: Global patent and IP portfolio, a defensive and offensive array of software patents covering search mechanics, advertising auctions, and neural network management. For open-ended questions for strategic analysis. 1. How can Google optimize the physical allocation of its limited compute resources between legacy high-volume search engines and modern, compute-heavy generative AI loops? 2. What talent retention frameworks must Google adopt to protect its elite research teams from aggressive poaching campaigns launched by agile, venture-backed AI startups? 3. As public web scraping becomes increasingly restricted, how can Google protect the value of its raw data moats against competitors relying heavily on synthetic data? 4. To what extent should Google transition its hardware focus from centralized cloud servers to decentralized, on-device edge AI processors? For explanations of core mechanics. Hardware-software co-design. By building both the software algorithms, Gemini, and the underlying hardware chips, TPUs, Google minimizes architectural bottlenecks, extracting significantly higher performance per watt than pure software firms. The data flywheel effect. Google's massive data asset improves its algorithms, which attracts more users, which in turn generates more behavioral data. This self-reinforcing asset loop makes the core search product increasingly difficult to replicate. Infrastructure commoditization defensive wall. The multi-billion-dollar capital expenditure required to replicate Google's global server and fiber footprint creates an absolute barrier to entry for standard market competitors. Human capital intensity. In high-tech business models, code optimization is an exponential lever. A breakthrough design by a small group of researchers can save hundreds of millions of dollars in processing costs across the entire data center grid. For implementation plans for resource optimization. Plan 1: Next-generation TPU fleet rollout, transitioning primary AI processing workloads to the latest internal TPU clusters to drive down inference costs. Plan 2: Zero-loss data pipeline deduplication, overhauling cloud storage ingestion systems to clean and compress training data, maximizing storage efficiency across historical datasets. Plan 3: Edge computing model pruning, developing highly optimized versions of foundation models designed specifically to run on local smartphone hardware assets. Plan 4: Private subsea cable redundancy expansion, investing in upcoming transoceanic fiber routes to bypass highly congested geopolitical choke points, securing direct bandwidth lines. For implementation processes. TPU deployment lifecycle, architectural tapeout, then silicon fabrication, then cluster integration, then compiler optimization, then inference allocation. Data asset pipeline, telemetry ingestion, then anonymization scrubbing, then vector database mapping, then AI model fine-tuning ingestion. Talent sourcing funnel, academic research sourcing, then specialized hackathon assessment, then peer panel interview, then core lab assignment. Infrastructure scaling, bandwidth demand spike, then dynamic route optimization, then subsea cable allocation, then regional edge node caching. For actionable recommendations: isolate proprietary training stores. Quarantine primary user interaction datasets behind custom security fabrics to ensure data assets cannot be systematically harvested by outside bots. Accelerate internal silicon independence. Actively transition standard data processing infrastructure away from third-party server chips toward custom-designed, power-efficient processors. Diversify academic research pipelines. Establish deep, multi-year funding partnerships with secondary-tier global universities to capture top technical talent outside typical recruitment hubs. Unify knowledge graph schemas. Consolidate historical semantic metadata arrays into a single, highly integrated graph asset to accelerate contextual conversational AI lookup times. For immediate to-do items: 1. Complete a comprehensive infrastructure performance audit across European data center zones to identify processing inefficiencies. 2. Update global access control policies for internal developers interacting with core training datasets. 3. Review current patent application pipelines to guarantee immediate defensive coverage for newly engineered neural architecture modules. 4. Calculate exact compute cost reductions realized when offloading tasks from external cloud platforms to proprietary hardware clusters. For practical techniques: dynamic load balancing, automatically routing computational requests away from overheating or high-energy cost data centers to regions with active clean energy surpluses. Knowledge distillation, compressing large neural network models into lightweight, highly accurate software assets that require fractional processing power. Predictive infrastructure telemetry, running continuous machine learning diagnostics on cooling systems to prevent hardware degradation before mechanical failure occurs. Automated data tiering, moving older, infrequently accessed system log files to colder, cheaper storage mediums while retaining high-speed pathways for high-value user data. For practical steps for execution: 1. Allocate an isolated subset of current data center compute cores specifically for testing early-stage hardware prototypes. 2. Conduct direct technical capability reviews on incoming engineering hires within 90 days of onboarding to optimize team placement. 3. Deploy upgraded hardware encryption modules across all multi-continental underwater fiber landing stations. 4. Integrate real-time storage monitoring tools into the primary search index management console to track storage consumption trends. If you found this breakdown of Google's core infrastructure assets valuable, Please take a moment to like the video and subscribe to the channel so you never miss our deep dives into business strategy. While you are down there, make sure to check out the links in the description below to download the free study materials or handouts, access the free, advanced chapter, online tutorials for an even deeper strategic look, and share the video with friends who might need it. The information presented in this channel is compiled with the assistance of AI, public sources, and independent analysis. While every effort is made to ensure accuracy, information may contain omissions, inaccuracies, or interpretations. Content is provided solely for educational, case study, commentary, and entertainment purposes and should not be considered financial, investment, legal, or professional advice.